Stanford University.
All right, again, thank you for inviting me to kick this off. I think it's definitely a pleasure to come in and talk a little bit about Ford, what we're doing to be part of this, and more importantly, maybe give some insights into what we see in terms of the market, the technology, and where things are going in electrification. And actually, it's interesting because we kind of changed in the industry. We used to call them all hybrids, and now with so many different variations of the technology, now we're starting to use the word electrification, which refers to hybrids, plug-in hybrids, which combines something else with the battery and then the battery electric vehicles. So again, I'll give an overview and then I'll get into some of the technologies that we're using and wrap it up with some of the things that we're doing in terms of interfacing with the home, the grid, and being part of the overall cycle and the infrastructure. To probably some people's surprise, the electrification and electric vehicles have actually been around for a while. It's interesting, this is an actual letter that was written to Ford Motor Company in 1914, asking, is it true that you're going to put an electric vehicle on the market and then I'd like to supply some parts for that vehicle. If you look on the left-hand side, there were 27 companies in the early 1900s making electric vehicles. And in 1912, an electric roadster was sold for $1,750, while a gas was sold for $650. Now, we all know what happened. Gasoline technology took on, and really there were a whole lot less electric car companies between the early 1900s and today. And it's having the electric starter, having the convenience of the gasoline vehicle and technology really kind of slowed down quite a bit. And for the last 100 years, there hasn't been a lot of electric cars. So what are we doing? This is actually the Ford corporate strategy overall for sustainability, not just electric vehicles. And I just wanted to highlight where the electrification falls into our strategy and where we're going. And I'll also give some industry view outside of Ford, just in general, of what other OEMs and consultants see the industry. We have had hybrid electric vehicles with gasoline powertrain and a battery on the market for about 5 years now, with the introduction of the small SUV Escape Hybrid. And last year, we introduced the sedans with the Fusion Hybrid. And today, actually, we introduced at New York Auto Show the Lincoln MKZ Hybrid that will be launched in a few months. So we have 5 or 6 hybrids on the road by the end of this year. What we are doing is introducing the more hybrids and plug-in hybrid technology and battery electric. And I'll get a little bit into the detail of the technologies in a few minutes. And we're starting to do that in the next couple of years. And I'll go through the introductions and what we've announced in terms of the products. Now, there are a lot of introductions that you'll hear, and that's really the exciting part in the industry today is compared to what we've seen in the 80s and 90s, there definitely has been a tremendous acceleration in the introduction of these technologies. So our plan is to introduce and to expand the introduction of the technologies, ramping into high volumes in the 2020 and beyond. I'm not going to go through a lot of the other sustainability items. As you could see, the key message is that electrification is not the only solution. And that's really important because while there's a tremendous improvement in the technology, energy density of batteries, cost, affordability, we still see a place of a lot of traditional, conventional evolution of conventional technology, like, for example, downsizing engines and direct injection and continuing to get better fuel economy with traditional technology is still a cornerstone until some revolution that would need to happen to make the electrification really equivalent to what we see with the conventional technologies. Some of the products, we have the hybrid, the full hybrid, and I'll explain the different types of hybrids. We have the Escape plug-in hybrid technology. We've had several of these vehicles on the road in test fleets since 2007. This is a plug-in hybrid with lithium-ion battery. We are introducing the Transit Connect Electric, which is an all-electric up to 100-mile range later this year. So this is going to be on the market. It's a commercial van. And then next year, we're going to introduce the Focus battery electric vehicle, again with range up to 100 miles with lithium-ion battery technology. And you could see some of the architecture here, and I'll go through that in a couple of minutes. Okay, it's kind of an overview of the introductions. And as you could see, when you add this to all the other introductions in the market, there's no question that this is a pretty exciting time. The consumer is going to have a lot of options out there, whether it's hybrids, plug-in hybrids, or battery electric. So as I mentioned earlier, the Transit Connect is launching by end of this year. Two battery electric cars, basically, from Ford will be out within the next year, 2010 and 2011. And then we're introducing a plug-in hybrid with a gasoline powertrain and a large battery that you can plug into your garage and extend the electric range on that. And when you run out, you still have a traditional hybrid, so you can still run it on hybrid. And then on the hybrid electric, we're introducing the next generation with lithium-ion battery technology by 2012. This is all in North America. Globally, we are launching the global products with the same architecture also in Europe, and we're also looking at Asia. The interesting thing from an OEM perspective or Ford or other companies, what's really important to get the technology more affordable is we're leveraging the global platform. So it makes it very easy to take a Ford Focus, for example, a small C-size vehicle, and introduce it in different markets. The platform will have capability of almost 2 million vehicles across the globe in North America, South America, Europe, and Asia. And that same platform, once we design the architecture and the system, we'll be able to launch it globally. And that's what we're doing. You could see the same products, left-hand drive, right-hand drive, in different markets that will have the battery electric plug-ins and HEVs. So let me talk about the overall view from the different types of technologies. As I mentioned earlier, we make hybrids today, and we continue to expand hybrids. But really, from a production standpoint, we have about 50,000 hybrids that we make every year in 2010, and no plug-ins or battery electrics in terms of volume. So by 2015, as I mentioned, some of the products that I was talking about earlier will have a portion of the fleet that will have plug-in hybrid, and a portion that the remaining will have battery electric. By 2020, we see the piece of the pie of plug-in technology growing within that fleet. Now, this slide is an industry view, not a Ford view. What we've done is just taken a lot of the third-party surveys and studies and analysis and combined it all in one chart. So what you see here is looking at the global, in the different markets. In the U.S., and this is a 2020 view of electrification. You could see here somewhere around 3 million vehicles, hybrid electric globally. This is global. About 1 million plug-in hybrids, and 500,000. This is in the U.S. In Europe, it's a similar breakdown, although you see more plug-in hybrids in Europe as a percent of the total. Some of the challenges that we see in Europe is because diesel is a pretty common offering, it's very difficult to compete with diesel on a small diesel vehicle in terms of fuel economy with a lot of the subsidies and the infrastructure on diesel. Now in China, again, it's somewhere in between. You could see that, again, hybrids, plug-ins, and then maybe a little bit more battery electrics. And some of the analysis shows that because of the congestion and a lot of the city driving, we could see more battery electrics in China as a percent of the total. And then you could see in Japan, it's fairly similar in terms of percentages to the US. Now, OEM View, and again, this is based on more announcements and views from the different OEMs. And this view varies significantly. So when you look at all the way from Nissan with more electric versus hybrids and plug-ins, you have GM more plug-ins than hybrids. Daimler has all three, VW with the hybrids and the BEVs. And then here's where Ford is. And that's similar to what I was showing earlier, where more hybrids, and then it's more consistent with what we see overall from the industry in terms of percentages. And then you could see with Toyota, Hyundai, and Honda more around the hybrids. Obviously, there are a lot of announcements, and a lot of the announcements can be very confusing. This is more of a general view by OEM. The affordability piece and the cost, and this is what we do. I have the fortune of leading the engineering team and the program team in Ford to deliver this. So end of the day, we've got to make this technology affordable, commercialize it for the consumer in order to grow the volume. So what we see in terms of cost, which will reflect in obviously the affordability, is we do see the battery electric cost coming down at a fairly steep rate, followed by plug-in hybrids, followed by hybrids. And the reason is the industry has been working on hybrids for a while, and we're bringing the cost down. And at this point, it's a fairly aggressive cost from work that's been going on for 10 to 15 years. But we do still see it coming down. And this is going to be a key piece because as I'm going to show you later, with all of the optimism, what we need to make sure is we can make this affordable so we can grow the volume. Right now, hybrids are only 2 to 2.5% of the market. It is still a fairly small percent, even at this level of cost. This chart just attempts to show the different types of electrification, and let me take a minute to go through this. As an industry and as from the consumer standpoint, I think I would probably say that there's a lot of confusion about what a hybrid is. So this goes all the way from a micro hybrid or a start-stop technology. So when you stop at a traffic light, the engine just shuts down and then it turns back on as you move. That's as simple, and it uses a traditional 14-volt technology. Then a mild hybrid with 42-volt battery. Those have really been getting less and less in the market. There were a couple of introductions, but we don't see that growing in the future. Medium hybrids with 100 to 160 volt hybrid. I think Honda has probably the high volume in that area with the Insight and the Civic. Then where we are, and this is what I want to focus on in this discussion, is the full hybrids, which the area down here is what Ford is producing and planning to produce. The full hybrids with a 300+ volt battery, the plug-in hybrid architecture based on the full hybrid, and then the battery electric. On the right-hand side, you see that the capability varies significantly, all the way from a simple engine start-stop to downsizing the engine. You use it as a generator, to regenerative braking. And regenerative braking, by the way, is actually the most significant fuel driver for fuel economy in a hybrid. As you use the kinetic energy and you're able to store that energy back into the battery. And one of the reasons full hybrids get you get more improvement down here is you have a big enough battery that you can store a lot of that kinetic energy. Then you have electric launch, which generally you don't have at the low voltage. There is not enough battery to be able to launch the vehicle in electric only. And then you have an all-electric drive. And again, this area down here is where you could start seeing at low speeds and even at mid speeds now, you could have a fairly good amount of electric drive without the engine. And on the right-hand side, you can see the improvement in fuel economy. The interesting thing on the technology side is all of these different types of vehicles use fairly similar technologies. And I'll just run through them quickly. They all use a battery. Now, there are different types of batteries. They all use electric AC, because when you want the air conditioning or the defrost to run, you don't need to turn on the engine. You can run it off the battery. A DC to DC converter, which is basically an alternator that runs off the battery. Regenerative braking system for fuel. Motors to drive the wheels. Inverters to convert the energy from the battery to drive the motors. And a transmission or a gearbox. And then for plug-in hybrids and battery electrics, charger. So the one thing that we look at from a technology standpoint, we're trying to get the technology, the efficiency, the cost, the weight, the size, all in the right direction, and it applies to all of these vehicles. This shows in this case, the Escape hybrid architecture, and I'll just highlight it quickly as I showed the parts. You have an electric you have the transmission here with the two electric motors. One is the traction motor and one is the generator. You have series regenerative braking system and the battery in the back. And all Ford hybrids, not all hybrids in the market, but all Ford hybrids are ATPZEV, Advanced Technology Partial Zero Emission Vehicle Standard. So the lowest emission standard that we can achieve with hybrids. One of the things that I wanted to highlight is we got our engineering team in Dearborn, Michigan. And on this architecture, there are over 200 patents. Just this actually happens to be just on the control system. Half the work that we do is the software, the controls for all the components, and a tremendous amount of it to try to get the smoothness, the fuel economy, and the drivability and performance without the customer feeling any difference. That's the success, is for the customer to drive the vehicle just like they drive the regular vehicle and not have to do anything different. How the system works is you can see at low speeds, the battery drives an electric motor that drives the wheels. And at moderate speeds or high torque demand, you could have a split, meaning we manage the energy from two sources. So you can have the engine through the generator can store energy in the battery and the battery driving the traction motor, or you can have the engine directly driving the wheels. And we manage that transition, and we also manage the amount of power that goes between those two at any point in time. The other thing we do is looking at all the different system and trying to get the best fuel economy out of the system. We work on optimizing the system, and it's not just the components, but it's how you size the system, how you run the components at different voltages and currents. So in this case, it shows we were able, for example, from the first generation to the second generation, which is in the sedan and the Ford Fusion, we were able to downsize the battery, therefore bring the cost down, and be able to generate power or torque as needed through a boost converter, through a voltage, basically booster, to run the electric motors. So when you're merging on the highway for a second or so, we're able to provide that power but not carry a battery that provides that power all the time. And by running at lower voltage, we're able to actually reduce the losses in the motor and the generator, therefore improving the efficiency and therefore the fuel economy. Shifting gears a little bit into plug-in hybrids, we're taking that architecture that I just described, putting a large battery in it, validating the components because you have more electric drive, with a charger, and that turns it into a plug-in hybrid, basically. So and I'll show how that works. So an electric drive, you can go up to a certain speed, 40 to 60 miles an hour on all electric. And only when you are demanding, again, significant amount of power, the engine will come on for a small portion. And then you got a big enough battery that you charge at night that you can use for extended drive. And the bigger the battery, obviously, the more range you get. When that battery is depleted, the vehicle will turn into a regular hybrid. So the worst fuel economy you'll get on a plug-in is the same as a hybrid electric vehicle. And that's where the battery is depleted to a specific SOC or a state of charge. The modular approach we use, and again, we're trying to clearly make the technology so it's affordable into the plug-ins and battery electrics. On the plug-in architecture I just described, we're able to test and validate the components that we can use the same components. All of these greens, we use the exact same components between hybrid and plug-in hybrid. And the only difference is you'll have the different energy battery versus a power battery. And you'll add the charger and then add more cooling. As a lot of these components run on extended electric drive, like the motors, you need to provide more cooling. It's basically e-pumps or electric pumps that run off the battery for extended periods versus a hybrid. And by doing this, we're able to, again, to bring the cost down, yet still provide the functionality. And as we try to do with common parts, high volume, low cost, affordability. A lot of different architectures out there, and I won't go through each one of these, but you hear a lot of different, even within the hybrid. If you're talking about a full hybrid, there are several architectures. This shows a parallel hybrid with a single motor. Some OEMs are doing that. You have a series hybrid, or some call it extended range electric, where you're always going through the battery. Or in our case, the power split hybrids, which shifts between the two. Net, the key is how much, what is the benefit versus the price or the cost that the customer have to pay. And in our case, we feel that this architecture provides the value. There are merits to every one of these architectures that's slightly different for different drive cycles. Let me get into everybody always talks about batteries, so let me just touch on batteries for a minute. Today, pretty much all hybrids on the market, I said almost all, there are a couple there, but almost all use nickel metal hydride chemistry. In the future, what you see, all the OEMs, including Ford, we're shifting to lithium ion technology. And the reason from a vehicle standpoint is pretty obvious, because you can shrink the size of that battery almost by half. Also, the weight is reduced, and the efficiency goes up by a few percent, which translates into fuel economy. So lithium, as the right chemistry provides a lot of these, and that yet, and I'll show you some of the validation is still ongoing to make sure that it provides the durability needed and cold temperature performance and others. And as we shift to plug-ins and BEVs, you could see that there's a slight difference in a battery electric. You could potentially use the same cell. However, you do want more energy out of the battery electric versus more power out of the plug-in hybrid. So just to give you an idea to compare the technologies, the battery technologies. Today, if you have a 23 kilowatt hour, which is generally a good number for a small size vehicle to go 100-mile range in a what we call a mild cycle, we call it a UDDS cycle. So that's roughly it weighs about 500 pounds, and the size of it is about 125 liters. For an EV battery, you could see where we want to go with the next generation is reduce that to about 400 pounds and 100 liters. Where we want to continue to progress is to 150 pounds and 75 liters. I mean, it's obvious, the smaller, the better. To compare that to a fuel tank, to get the same energy it weighs 125 pounds and 60 liters. So the point is, we still got a long ways to go as an industry to make it equivalent to what the customer is used to today. Now, battery chemistry and technology and readiness. This is a USABC. The battery goal versus actual performance is still, you could see here the discharge power, which is basically means the power you get by driving, that you're demanding. Charge power is generally what you put in through regenerative braking. Power density, we're meeting it as an industry. Specific energy, a little bit short. Energy density, a little bit short. Cycle life, which translates into the 10 years, 150,000 mile durability. A lot of promise in the data, a little bit lacking on the calendar life because of the chemistry. Now, the challenge is cost, nowhere near where we need to be. Temperature, especially at cold temperatures, with lithium plating and some other phenomena within the chemistry, especially when you get into an EV, a pure EV, because you don't have an engine to supplement that cold temperature issue, like in a PHEV or a hybrids. It becomes a real challenge. And generally, below 0 C, you start seeing some limitation into the power or the performance that you can get out of an EV. So that's a general chart, mostly accurate in terms of what we see with the different chemistries. The good news is there are, I would probably say, tens of billions of dollars that are being spent on lithium-ion battery technology globally. And I've had the luxury of visiting most of the manufacturing sites and R&D sites, both in Asia here and in Europe. And it's a very promising effort, and I do believe we're going to see some significant improvement in the next few years. Again, this is another way to look at it in terms of specific power and specific energy. This is where we need to be. This is where we are today. Let me get into the rest of it, because it's not all about batteries. When you look at the system drivers and how we approach the technology, we look at the use of the vehicles, the drive cycles. At Ford, we have 45 different drive cycles from different cities in the US and globally. And we look at the worst case cycle for each component. So if you have a component in the system that has limitation on thermal cycling, we look at what worst cycle in what city, in what terrain that we have to meet. And that's what we run the component to. On the technology, especially with power electronics or IGBTs and diodes, there's quite a bit of cost and opportunity to shrink it and get the cost down still. So it's not just the batteries. And then on commonality and use, trying to figure what I was describing is how do you take these components and be able to transition those for different technologies. To give you an idea, any of those components that I described will cost several $1 million to engineer. So if you just have one component and you're engineering a specific component, it's easily, you could see easily $5 to $10 million of engineering to engineer one component. And the more unique engineering you do, then the affordability becomes an issue. Again, I talk about examples you have in terms of drive cycles. Sometimes on the component it could be low speed, city driving. It could be high speed, hilly terrain, towing, off-road driving, very high speed, Autobahn type driving. So we look at all of these different cycles and we design the components to meet the worst case. This is just our product development philosophy. Again, what I was describing, we take the different drive cycles and we meet the 90th percentile customer, in terms of the worst case on the worst cycle. We develop the cycle, we translate that cycle into a drive profile for the component, and then we develop the component testing, and in this case, it's the inverter, and what we call it is a key life test. And to give you an idea, you could run some of these key life tests after you develop the component it could be up to a year where we're running that component to validate that 10-year, 150,000 mile durability. Again, this shows we talked about batteries. This shows the inverters and where the technology has been going. Clearly, we're going to continue to see improvement. And again, it shows you that the energy and the technology is not just going into the battery. It's going through every component. Now, let me shift gears a little bit. We talked about components, technologies, modularity, platform. One of the things that we learned is the customer, and in this case, it's on the hybrids, because we've had that in the market. You could design the best technology, you could design the best powertrain, but the customer drives a car, not a powertrain. So the whole experience of that driver matters tremendously. And I'll give you an example. And I personally did not think this was a big deal as we were developing this. But one of the things when we launched the Fusion Hybrid almost exactly a year ago, we had the best fuel economy in the segment, beating all the competition, smooth performance, both higher on performance and fuel. Yet when you read the blogs and when you look at the customer feedback, they actually care more about the information that's being provided in the cluster than what the powertrain is actually doing. And in this case, we had put LCD displays where we provide a lot of information, and I'll highlight a couple. This piece here, it's actually a dynamic display of where the driver is versus where they're going to get out of the EV mode. So if you can actually tell as you're driving when the engine is about to come on. What we learned is we thought it was a neat thing to do. Customers think it's critical because they were actually adjusting their driving based on what that was telling them. So as they're approaching, when the engine is coming on, they actually back off as they're driving and then keep it in EV mode. And then even positive recognition where we actually grow a tree with leaves as they're doing better on fuel economy. It was, for a lot of engineers, they thought it was a little tacky. But I'll tell you, customers love it. And they actually strive to get more leaves. And in the Lincoln that we just revealed today in the New York Auto Show, if they continue to do well over time, it starts growing flowers on top of the leaves. So they love it. It's great. I mean, the point here, I think, is the whole experience of the drive and dynamic feedback to the driver became really critical. And they will customer will modify their driving based on that information. So needless to say, that's an area we're focusing on now. So now let's talk about plug-ins for a minute and outside the car. I mean, we're not going to make plug-in hybrids or EVs successful just by car companies making great products. Clearly, the utilities, the home is a huge part of it. Today, as we all know, it's independent solutions. You have your appliances. You can have other sources of energy coming into the home, batteries, windmills, and cars. Everything is separate. They don't talk to each other. What we're experimenting with, and a lot of help from utilities and industry and even and government, is looking at an integrated solution that targets filling the grid, if you will, through off-peak times, and making the vehicle part of the home as you're charging it off-peak, and you're able to manage the capacity through off-peak times. This requires a lot of technology and a lot of integration. It's not just what we learned also, just like I was showing on the cluster. It's not as simple as we know the customer is going to go plug in overnight and everything will be perfect, and they do that every night. It's not that simple. So we also learned through, we had 20 Escape plug-in hybrid fleets in different utilities and with customers in the last couple of years, is they need a lot of information for them to change or adjust how they're charging the vehicle. So some of the things that we have done, again, through partnership with the utilities, and one of them is Southern California Edison, which has a lot of our vehicles down in LA. We have created interface solutions, and we've been testing it to provide, again, a lot of information to the customer and also allow the customer to input what they want. So in this case, we used an open protocol with similar electronics that you see in appliances, in smart appliances, where we turned the nav system in the vehicle into a programmable thermostat, if you will. So you can actually go in, the customer would go in, and they would put in when they want to charge the vehicle, what rate they want to pay. Again, that will require feedback from the utility, what rate they want to pay, and how long they have. So obviously, we're going to, if they don't have enough time to charge, we're going to charge it at whatever rate. But if they have time, we will not charge it until the rate is the lowest. And just similar to what you do in your house with thermostats. And that technology is all available. Things that we actually have on these vehicles, and they work. The other thing which is really important is can the infrastructure and can all the homes and the utilities manage all this? And the question is maybe, and it depends. If you look at, for example, on a typical home, you have an existing design home, 58 to 80 to 87 amps. When you put in an electric vehicle, plug in into a home, let's say on 240 volts, or what we call level 2 charging, you're using up quite a bit of that. As a matter of fact, a good rule of thumb is if you're charging your battery in your vehicle, you are about doubling the use of electricity as you're charging that car for that home. So it's pretty significant. Now, for a home, that may be okay. The question is, how many homes are on a transformer, and can the transformer handle that? So those are all the things that we're looking at. And of course, if you're going to have plug-in hybrids or battery electrics that are a small volume, it's not a big deal. But if we're looking at, as we are looking at, 10 to 20, 25% of vehicles on the road getting to that technology, that could become an issue. Earlier today, we announced again at New York, we're taking the, Ford and Microsoft have been collaborating on a lot of technology, including some, communication sync technology. We just announced another collaboration, which is actually an open architecture. So any OEM can use it. It's not exclusive to Ford, but it's starting with Ford and Microsoft, where it allows the customer to use the information of the electricity use in their home, including the vehicle. So they'll have it available with the Ford vehicles and all their appliances to make better choices on how they're using the electricity in their house and how they're charging their vehicle. So it's a full solution around their house. It's an application software that basically combines those two. And all they need in terms of capability is access to the internet. There is no special hardware or software that they need in their house. So again, just one other example of what we're doing to make this more, make that communication piece as we learned from the hybrids. So this is what I was describing. You could basically, it combines a full, it's called the Microsoft Home, and it combines appliances, all the use of your house. So you actually know what you're spending your electricity on, whether it's your appliances or your car, and you can adjust. So what I would describe, again, the smart metering technology, the technology that I was showing in vehicle, the nav systems, all that link and that communication, which the interesting thing is all of this is available technology. This does not require breakthrough in technology, software or hardware. Clearly, we have to commercialize it to the point that it becomes affordable, which is what we're working on. But all of this is stuff that's available, and even indication of how you're charging, how much you're charging. You could actually have the information text to your phone. You could have it on the internet. You could see how your vehicle is being charged. How is it full charge? Is it not? And even command the vehicle to do certain things. This shows, again, again, you got the automotive vehicle, utilities, which in the past we haven't been talking. Now there certainly is an overlap, and it's all the stuff that I was mentioning earlier. And across geographic markets is the next challenge. As you may or may not know, in the US, there are thousands of utility companies. Unlike in some other countries like China, where there's a lot less, it's probably more manageable. But this is a big task, but as an industry, we've got to make that work to make this technology commercial. Again, when you look at different charging, you could charge in different locations. You can charge in your house. You can charge at a depot. You can charge at work, or you can charge in public. And this is all enablers. The more we could do in terms of the charging infrastructure, the more this technology will be available. Now, the plug-in vehicle charging standards, which is also critical to the success, because you don't want a charging system that is unique to a particular OEM or Ford or Toyota or whatever. You want a standard charging system. In this case, there are a couple of key standards that we're all rallying around for implementation. The first one is the 1772, which has three different levels. Level 1 charging, which is your regular 110 volts in your garage. Nothing needs to change there. The level 2, or 220 to 240 volts, that does require, in many areas in the country, in the US, doesn't require anything in many European countries, but it does require changes, and I'll show you what that is. And then level 3, which is DC charging, which that is not really feasible in the short term at home. That would probably be targeted more towards public locations. Again, in terms of charge times, the other thing we're trying to do is make sure the charge time is reasonable, because if it takes you 15 hours to charge your BEV, you're probably not going to buy it. So what we're trying to target is 8 hours or less overnight, probably more around 3 hours to make it, if you're going to work or in public stations, become even a challenge. So we're driving hard to reduce the number of hours that you can charge it. We believe that a PHEV level 1 is okay, level 2 is clearly better, and in a BEV, you're definitely going to need level 2 to have a reasonable amount to charge your vehicle. The cost of charging is roughly about $2,000 for a level 2. This is changes that you'd have to make to your house with what's called the EVSC module, and then running the 220 volt out to the garage. And then for public charge point, because you got to do a lot more structure to it, it's about $7,500. Okay, so in terms of market readiness, if you look at this, current plug-in owners on average charge at least 2 times a day. The charge point availability is cited as the key adoption barrier. There's a lot of surveys and data that we've been interviewing customers or potential customers for this technology. And the interesting thing is, in one experiment, adding fast chargers, which basically chargers that you can charge your battery in less than an hour, at strategic city points, it increased the electric fleet vehicle use. Charge point usage did not actually increase. So the point here is range anxiety, or feeling that it's kind of like if you know there's a gas station nearby, you'll feel okay. You may not actually use it, but you'll feel okay. And it's the same thing with this technology. So the infrastructure and the customers knowing that there are enough charge points is key, again, for them to buy the technology. So I'll show you kind of 3 graphs real quick. This is in 2005, the volume by the HEV, because that's what's available today in the market, by region in the country. You could see that the green is where you have higher sales here, mostly in the coastal areas. California is definitely our biggest market for hybrids. This 2005. If you look at 2007, I'll go back to 2005. It doesn't actually change that much. 2009, again, it doesn't actually change that much. The point here is there needs to be a lot of work if we're going to be spreading this technology across different areas in the country. Right now, we know that California, the East Coast, and some other areas, which is really where the volume is for this technology. This is an interesting piece as well in terms of data that tells us who buys hybrid, why do they buy hybrid. And it's a bit overwhelming. You see that people react to gas prices. That's why they buy hybrids. And again, this isn't the early adopters, 6, 7 years ago. This is now hybrids are in reasonable volume. But as you could see, as gas prices go up, you start seeing the hybrid. The other interesting thing is it's fairly volatile. In other words, that people will respond to gas prices, but they will also respond to perception of where gas prices are going. And it takes time, lag, for them to forget. As you saw, a couple of years ago in the summer 2008, there was a big, gas prices went up. I know that just driving by dealerships, all the hybrids were gone. And when gas prices went down, you start seeing them again. So it clearly follows gas prices. Now, we believe that plug-ins are going to be similar. The question is going to be EVs. Is it just going to be gas prices, or it's something else? Again, the hybrid market is roughly about 2% of the market in the US, and globally, it's a little bit less than that. Okay, I'll just finish up here in a couple of minutes. Again, the message in terms of plug-ins and battery electrics is we've got to have certain things outside, within the vehicle and outside the vehicle. So we need aligned goals between the different industries, the automotive and the utilities, to make this happen. We have to continue to look for new business approaches. And I know that you have other guests that will be talking about different business approaches. We're very open to different business approaches because we know that the traditional approach may or may not work, or somebody may come up with a neat idea that would, people would look at EVs differently than the traditional. I got to go 400 miles and drive on the highway. And affordability. As I mentioned, we're doing everything we can to drive that affordability piece down to commercialize the technology. So it's not only auto industry, utilities, battery suppliers, governments have a lot to do on both sides, both the technology development and some of the early incentives that you see. And it's not just in the US. There's a tremendous amount of incentives in Asia and Europe as well. And then the consumer. And what it takes is really all the pieces to come together. With that, hopefully I gave you a little bit of an overview of what we're doing on the technology, cost, and future. Thanks. Questions?
Okay, great, thank you. That was fascinating. So will you take questions?
Sure.
Okay, all right.
Sure.
So anyway, questions. Okay, back there, raise your hand. Yeah.
Yeah, sure. Thank you for coming and giving the talk. It's very interesting. You talked a lot about the infrastructure and partnerships and kind of consumer expectations that are needed for passenger vehicles. But I noticed that the first vehicle that you guys are releasing that will be an electric vehicle is actually a commercial vehicle. Could you talk a little bit about why you chose to do that and what the infrastructure and partnerships and kind of user interfaces and expectations are necessary for a commercial vehicle?
Yeah, and our thought was actually commercial vehicles and certain types of commercial vehicles are easier to manage from an infrastructure. In the Transit Connect, which is a small commercial vehicle, it's a typical delivery vehicle. So usually you'd have certain drop-offs and certain routes that a customer would have, and then they would usually come back to the same starting point. So the thought here is working with some of these customers and having charge points at one location, and they know exactly what their route is, and they know what the vehicle capability is. They can continue to repeat that, and it's a fairly easy way to manage that without adding a lot of cost on the infrastructure. So that was the point in this particular application. Now, that doesn't apply to every commercial vehicle. So in certain ones, for specific routes, if you're looking at postal delivery, that could work very well depending on the route. That tends to be within that range. Other deliveries as well. It gets even in other. I've had the chance to look at some other use like buses in China. When China had in the Olympics a couple of years ago, they spent a lot of money, a lot of incentives to get electric buses for transportation. It was both technology development and it actually made sense because, again, buses you could do that with. So It depends. Commercial is there's a place for commercial. It's actually fairly easier once you know what the route is. The retail, most of the comments I was making, because the retail piece is more of the wild card, which you don't know what the customer is going to do.
Okay, next, Lindsay, how about over here?
So the electric vehicles have been around since the 1900s, and I assume that the oil companies had some influence on them going away for 100 years. So what's the oil companies' influence now?
Well, one, I can't speak for oil companies because I don't work for an oil company. But what I will tell you, though, is what I do know is looking at the technology that existed in the past, there are two big differences now. Back in the 1900s, what I do see is clearly the chemistry and the energy density and the power density, which gives you the range and the acceleration in vehicles, was way behind. And there has not really been significant research until, in terms of development of this energy density and power density and chemistry, until really the last 20 to 25 years, there have been a very strong acceleration in that. So what's different now is some of these charts I was showing, and if you were to add up the chemistry from way back then, it would be a lot worse than what we're seeing. So that's really what's changing for automotive. Working at Ford, I don't really see any oil companies affecting things either way. So we're just developing batteries and developing technology. So.
All right, maybe let's go to the back over here. Yeah, please. Yeah.
So following on the other gentleman's comment about small delivery vehicles and transit vehicles, are you guys also looking to get into developing hybrid or electric vehicles for trucks, delivery, like UPS, FedEx, semi-trucks, and airport delivery vans that deal with sort of closed loops? Or are you looking to grow that larger vehicles? Because those vehicles tend to run like 4 hours per day than the average person using their car. So they footprint a little bit.
Yeah, we're looking at it, and what we're trying to do, just to give you an idea of what drives the affordability or the cost in the batteries and this technology, the weight of the car is the #1 driver for lack of affordability. So the bigger and the heavier the vehicle, the bigger battery you put, and the cost of the battery goes up exponentially. So what we're trying to figure out, what is that sweet spot in terms of making sense for FedEx or making sense for those larger vehicles. In smaller vehicles, you can get away with a smaller battery and get it to an affordable point for that customer. Because again, we believe the customer isn't going to buy it unless it makes sense for them from a payback, especially commercial applications. That's how they run their business. So we're looking at it. It's capable. We don't see it. We see an affordability issue.
All right, how about over there in the blue sweater?
Yeah, you mentioned a lot moving to lithium ion. I know there are some companies that are doing early stage research, like Polyplug in Berkeley, on lithium air and lithium sodium, which supposedly has almost the same density or even better than fuel. But they're more in the early stage. I mean, are you trying to go down that path? Because from the energy density point of view, it's a lot more attractive.
We are. It's in research, just like everybody else. We're doing research on that and testing on the lithium air and those technologies. And that's we have a fairly large research group in electrification, and they feed. In my area, we do the production, we deliver the vehicles and the technology. The research piece feeds all that, and that's one of the key things that we're researching for the future. Probably not for incorporation in the next 2 to 3 years. It'll be beyond that. So I would not suspect that we'd see that in the next generation.
All right, how about
Do you anticipate there'll be a problem bringing enough electricity into the urban area if plug-ins become a major source of transportation?
I think based on what I was sharing in terms of the number of homes on a transformer and the number of transformers for a particular area, I'm not intimately familiar with how the density is in dense areas. What I was describing is more of a suburbia look at it. I would expect that if we're going to have a significant volume of cars, that would be an issue, especially if people aren't charging it during off-peak hours. So it could be an issue.
All right, we're going to just there'll be more opportunities for these things.
Way back when you developed the hybrid, how come later on you adopt the Prius system?
That's a good question, because that's a big misconception. We did not adopt the Prius system. The Ford system with the power split, the architecture with the two motors is the same as other hybrids out there. But there's not a single component, a single piece of software that is common with Prius or Toyota. So it's unique. We have a few hundred engineers that developed this technology, and it's all Ford technology.
Okay, well, thank you very much.
Thank you.
For more, please visit us at stanford.edu.